just some extra examples on finding domain of logarithmic functions. I think they're great review problems because we're going to have to solve polynomial inequality and rational inequality. I will do this, the problem C in this video, okay? So if I can copy this. Alrighty. So you know how to set this up. You do set it up as setting that argument greater than 0. That's step number 1. So remember to set this argument 25 minus x squared greater than 0. Now this is a polynomial inequality, so I will factor this. If I factor this, I get 5 minus x and 5 plus x, isn't it? Which means the boundary points are x equals positive 5 and x equals negative 5, because these two numbers, 5 and negative 5, will make this 0. So what do I do after that? I sketch a number line. So this is a review of, I'll go ahead and write that down. Review of section 2.6, polynomial inequality. I plot the negative 5, plot the positive 5, and I need to check the intervals. Left of negative 5, right of positive 5, and in the middle of, here you go, in the middle of negative 5 and positive 5. So let's see. Let me give her some toys real quick. All right, here you go. I will plug in negative 6 here. I'll plug in x equals negative 6 because that's smaller than negative 5. If I plug in negative 6, I will get 5 minus negative 6 times 5 plus negative 6. That is 11, right? 11 times negative 1. Oh, girl, there's no reason to scream. If I multiply these two, I will get a negative number, right? This is negative. Which means, I've been going for a while. I don't want to stop the video, so I'm just gonna go on. Now listen, what were they looking for? They wanted these two to be greater than 0, didn't they? They wanted it to be greater than 0. So if it says negative, this is not the answer interval. So I'm not going to highlight it. But look, speaking of that symbol greater than, because they said greater than, I'm going to draw open circles here. Not filled in circle. Because they didn't have a bar underneath it, I'm not going to color it. Now let's pick another value that's in between negative 5 and 5. I'm going to go ahead and plug in 0 because 0 is in between negative 5 and positive 5. So if I plug in x equals 0, I will get 5 minus 0 times 5 plus 0, which is 5 times 5, and that is positive, isn't it? So guess what? The answer interval is this one. In between negative and 5 and positive 5. Any numbers in between these two numbers, not including these endpoints, can be in the domain of this logarithmic function. But I should check the last interval. I'm just trying to be good here, okay? I will plug in a number that is bigger than 5. Plug in x equals 6. Then I will get 5 minus 6 times 5 plus 6. That is negative 1 times 11. Hey, if I multiply these two, I will get a negative. Notice, hey, stop. I wanted the interval to be greater than 0. Look at the yellow highlighted box for me. I wanted the interval to be greater than 0. So if it came out to be negative, that is not what I want. It's only the interval that's in the middle that will make the number that will make this argument positive. So here's the answer. Here's the answer. Now zoom out and say it. Domain of f of x is -5 to +5, but I must draw open circles and regular parentheses instead of square brackets because the endpoints will make it 0, but argument of a logarithmic function should not be equal to 0. It should be bigger than 0. So that is how you can do part C. It's a review problem, really. Setting it greater than 0 is the easiest part, but the fact that we have to solve this polynomial inequality, checking all these intervals, that was a great review part, really. But I will stop this video now so that I can show you the last one, where we're going to have to solve rational inequality to find the domain of a logarithmic function.